German tank crews expected superiority in armor and firepower to decide battles. Instead, they witnessed America. These tanks were guided by a hidden advantage, invisible to the eye but powerful enough to re-riff the entire nadir of armored warfare. February 1943. The Kasserine Pass in Tunisia had already become a crucible where Allied and Axis armor clashed under brutal conditions. The battlefield was a haze of dust, smoke, and confusion, a place where visibility collapsed to only a few dozen yards.
Commanders often relied on instinct as much as orders. Yet what German tank crews witnessed defied everything they thought they understood.
Sherman tanks advanced with uncanny coordination. Units scattered by terrain folds and olive groves suddenly converged.
To German eyes, this should have been impossible. Their doctrine demanded visual signals. Flags waved, flipped.
In the chaos of Kasserine, none of those methods could explain what was happening on the battlefield before their eyes. Inside Panzer IVs and assault guns, German commanders strained against the limits of their communication systems and failing equipment.
Their Fugue 5 radios, once cutting edge in the 1930s, sputtered with static whenever tanks moved or engines roared in combat. Electrical noise from engines and treads drowned out voices. Range collapsed to a few hundred meters, leaving leaders shouting uselessly. Worse still, only a fraction of German vehicles carried full transceivers. Most had receivers only, unable to reply or report.
The destruction of a single command tank, easily spotted by its antenna, could reduce an entire platoon to silence.
Throat microphones and noise-canceling headsets allowed Sherman crews to hear and respond, even amid the roar of battle.
Unlike amplitude modulation radios in German tanks, FM systems filtered interference.
In Italy's mountains, FM radios triumphed where German sets failed, maintaining contact across ridgelines and deep valleys.
German observers, writing after-action reports, struggled to explain what they saw. Some attributed it to American discipline or training.
Few realized they were witnessing a technological leap that transformed each tank into a node in a wider network.
The effect on the battlefield was profound. German armor had heavier guns, thicker armor, yet Shermans offset those disadvantages.
5 Shermans did not fight as 5 individuals, but as one organism, able to shift, cover, and strike. For German crews inside their turrets, the illusion bordered on supernatural, an enemy moving together with impossible coordination. Kasserine Pass ended in a tactical defeat for Americans, a harsh reminder of German battlefield skill and experience. Yet beneath smoke and wreckage, a deeper truth emerged. The U.S. Army had unleashed a weapon, invisible but decisive. It was not the 75mm gun of the Sherman, nor the thickness of its armor plates that mattered.
It was instead the invisible web of radio signals binding crews together, shaping their movements in unprecedented ways.
That revelation would not be fully understood in 1943, but in time, it proved transformative beyond.
The first demonstration had taken place in Tunisia, where German commanders realized with unease something far beyond tactics shaped battlefields.
The Americans had revealed a new dimension of warfare, the power of connection, unseen yet more decisive than armor. To understand why Sherman tanks could fight as a single coordinated force, we must look to American factories and laboratories. The transformation began quietly, long before U.S. troops ever met the Wehrmacht in North Africa's deserts or mountain passes.
On July 22, 1941, the U.S. Army standardized a new family of radio sets for armored forces.
The models were SCR-508, SCR-528, and SCR-538. Planners recognized mechanized armies lived or died by communication. The decision to standardize radios across tanks would prove revolutionary.
Behind these sets stood Galvin Manufacturing Corporation of Chicago, later Motorola, a company once better known for civilian car radios.
Crystal-controlled stability allowed Shermans to remain aligned on channels, even during combat vibration and heat extremes.
Dual receivers gave commanders unmatched awareness, following company orders while tracking platoon updates in real time.
Magnuski, a Polish-born engineer, solved technical problems of fitting sensitive electronics inside cramped, vibrating, dust-filled tank environments under combat.
Their solution was the SCR-508 system, centered on the BC-604 transmitter. A heavy,
Weighing over 180 pounds, the BC-604 was no trivial device, yet it brought battlefield clarity and reliability unmatched.
With 25 watts of power and crystal-controlled stability, it transmitted clean signals across miles, regardless of harsh terrain.
Most importantly, it used frequency modulation, filtering out static and distortion that plagued amplitude modulation under combat conditions. For the first time, tank crews could speak during battle and actually expect to be understood clearly under fire.
By contrast, the German Fug 5 struggled constantly. Its 10-watt output rarely reached beyond a kilometer when moving.
Electrical interference from spark plugs and motors corrupted transmissions. Many German tank crews heard only garbled noise and static.
Worse, German production never matched demand. A 5-tank Panzer platoon might have only 1 or 2 transceivers available.
Subordinate tanks often could not reply. Orders came one way from platoon leaders, their crews reduced to silent obedience.
If that leader's tank was destroyed, the platoon collapsed into chaos, its silent vehicles suddenly blind and leaderless. Entire units unraveled when command vehicles were hit. Doctrine and technology had created a single point of failure.
By contrast, American tanks avoided this vulnerability. Every Sherman could transmit, receive, and assume command if needed.
This flexibility gave Americans a hidden edge. Even when chaos struck, coordination survived.
The Battle of Kasserine Pass in February 1943 was the first large-scale test of these opposing communication systems. Though the Germans achieved tactical success, U.S. forces revealed a startling capacity to maintain contact across broken terrain.
Sherman crews scattered across miles, coordinated maneuvers, warned of ambushes, and called for artillery in real time.
German signals units intercepted transmissions, noting clarity and range their own radios could not achieve under the same conditions.
Reports concluded Americans maintained communication across distances where German units heard only static, a capability beyond training alone. By late 1943, American forces carried their radios into Italy, a battlefield of mountains, valleys, and broken roads.
In terrain where visual signals failed, American frequency modulation excelled, carrying messages clean through ridgelines and valleys.
German AM radios faltered in these conditions. Multipath interference turned every spark and echo into bursts of noise.
American armored units moved like water, flowing around obstacles while radios bound them together invisibly over mountains and rivers.
Reports from Italy described Sherman's coordinating beyond line of sight, something German doctrine insisted was impossible without visual contact.
On June 6, 1944, Sherman tanks carried their radios onto the beaches of Normandy, still linked.
Shermans coordinated not only with one another but with naval fire support offshore, creating a web of combined arms unseen before.
Yet the hedgerows revealed a weakness. Tank radios could not speak directly with infantry sets, creating fatal gaps in communication.
German infantry with Panzerfausts exploited this gap, striking tanks before nearby American riflemen could warn them in time. American crews improvised a solution, welding field telephones onto tank exteriors so infantry could speak directly to the crew inside.
Fleet tools. By late July 1944, Operation Cobra showcased the maturity of American radio networks, linking hundreds of tanks.
During Operation Cobra, American armored command posts coordinated hundreds of Sherman tanks through extensive.
Facing them was Panzer Lehr, among Germany's finest armored divisions, but crippled by radio shortages and failing coordination.
American tanks reported targets instantly. Artillery answered within minutes. German defenses cracked under coordination they could not match.
Operation Cobra shattered German resistance. The synchronized advance of American armor, bound by radio, forced breakthroughs impossible before.
For the Germans, Cobra exposed more than a defeat. It revealed their armored forces were fighting in silence against a connected enemy.
Ironically, Germany had pioneered tank radios in the 1930s. By 1944, most of their vehicles rolled into battle mute. Heinz Guderian, father of Blitzkrieg, once insisted that every tank carry a radio. His production shortfalls made the difference. In 1943, Germany built thousands of tanks, but only a fraction carried functioning transceivers. The contrast was staggering. Every Sherman tank spoke with its comrades, while fewer than 1 in 5 German tanks could reply. If German radio shortages were crippling, Soviet tank forces suffered even greater silence. Most T-34s rolled into battle mute.
Red Army doctrine relied on colored flags and pre-battle planning, a method disastrously inadequate against mobile German armor. In 1941 and 1942, Soviet armored losses soared. Units unable to coordinate Lend-Lease shipments eased the crisis. American radios, including SCR-508 sets, equipped some Soviet command tanks by 1943.
Even by war's end, only about 1 in 4 Soviet tanks carried radios. By contrast, every Sherman had one installed.
In Chicago, Motorola's factory represented America's industrial mobilization at its peak.
Each SCR-508 required over 2,000 individual components, manufactured to exacting standards to survive the shock of combat.
The BC-604 alone contained hundreds of capacitors and resistors. Each part had
Production soared. In 1942, 3,800 units. By 1944, over
Think Len. This miracle ensured all 49,324 Sherman tanks built time carried radios. Crystal-controlled frequency stability meant Shermans could preset channels and remain aligned despite heat, vibration, and battle shock.
Dual receivers allowed commanders to monitor both platoon and company nets, keeping orders flowing while tracking subordinates.
The BC-606 intercom tied every crew member into the system, ensuring threats were reported instantly to the commander.
German tanks often lacked intercoms entirely. Crews shouted over engine noise or tapped shoulders, slowing their reactions. Power management gave Shermans another edge. Their dynamotor supply filtered interference, while German sets picked up every spark as noise.
Universal radios enabled flexible combat commands. American units could form ad hoc groups, confident their radios would keep them linked.
Shermans could instantly report enemy armor, directing tank destroyers toward threats even when out of direct sight.
Observers embedded in command tanks could call devastating barrages. Their requests relayed within minutes across radio nets.
Even against superior Panther tanks, coordination gave Shermans an advantage. They fought as a system, not as isolated machines. At Ericourt in September 1944, Shermans destroyed 281 German vehicles.
German intelligence noted American coordination, but attributed it to discipline and training, missing the decisive role of FM radios.
They assumed destroying command tanks would shatter U.S. cohesion, unaware every Sherman carried the same communication power. Ambushes were planned on the assumption Americans could not regroup if separated. Yet radio kept units connected beyond sight.
German reliance on runners and visual signals collapsed under artillery and airstrikes, leaving formations fragmented and leaderless.
Meanwhile, American formations advanced like a living organism. Each tank reinforced the other, cohesion unbroken by terrain or chaos.
By March 1945, the American radio network stretched across Germany.
At Remagen, U.S. forces captured the Ludendorff Bridge intact. Radio reports carried the news within minutes to headquarters.
Divisions across the front shifted instantly. Within an hour, units were converging on the bridgehead to exploit the opportunity.
Radio coordination turned the bridge into a fortress. Tank platoons from different battalions integrated seamlessly to hold the crossing.
German counterattacks arrived piecemeal, uncoordinated. Without reliable communication, they were destroyed in detail at the crossing.
Weeks later, the Ruhr was encircled. American armored columns converged from north and south, coordinated entirely through radio networks.
Sherman platoons from different divisions moved as one, their cohesion sustained across miles by constant radio contact.
German units relied on telephone lines, many destroyed by Allied aircraft. Communications collapsed as the noose tightened.
Inside the pocket, units lost contact with headquarters and each other, reduced to isolated resistance with no coordination.
Walter Modell's last reports described the disaster. No contact with neighbors, no word from headquarters, coordination impossible. For American crews, radios offered assurance. Even when separated or surrounded, they knew their voices could always be heard.
German tankers faced isolation. With radios scarce or broken, crews fought individual battles, blind to the larger struggle.
Otto Carius, one of Germany's best tank commanders, later admitted that poor communications compounded every danger his units faced.
American advances in 1944 were fueled by speed. Radio networks kept momentum across hundreds of miles, bypassing German defenses. Even late in the war, many German officers still underestimated American radios, mistaking coordination for rigid discipline alone.
Flanks. By late 1944, Heinz Guderian acknowledged that American battlefield coordination, enabled by radios,
American intelligence teams confirmed it. German radios lagged years behind. Their equipment simply could not compete with FM clarity.
Technical Intelligence Report No. 176 concluded German tank communications were 5 years behind, crippled by interference and poor design. Soviet evaluators reached the same conclusion. Post-war, they chose to copy American designs, not German, for their new radios. The numbers told the story. America deployed over 50,000 tank radios. Germany managed barely 6,000 full transceivers.
When West Germany rebuilt its army, radios became the first priority. Every Leopard tank carried comprehensive communication systems.
A Bundeswehr manual declared, "The defeat of superior German tanks by American Shermans proved communication outweighed firepower." Decades later, the Gulf War validated the lesson. Coalition forces with superior communications crushed Iraqi armor despite Soviet designs.
In 2003, digital battlefield networks continued the principle. American units
Modern tanks from Leopards to Abrams carry this inheritance. The lesson of the Sherman lives on in every connected battlefield. The Sherman's SCR-508 was more than a radio. It was the seed of modern networked warfare, binding machines into a single organism.
The war proved a paradox. German guns and armor outclassed Shermans on paper, yet invisible radio waves decided the outcome.
At surrender, German leaders recognized the truth. Tanks win battles, but radios win wars through unity and coordination.
From Tunisia to Normandy, from France to Germany, the Sherman's radios forged unity that German forces never truly understood.
Warfare's truth was written in invisible lines. Connection ensured survival, while isolation guaranteed defeat.
Every Sherman carried not just steel and firepower, but a lifeline. 181 pounds of radio equipment that bound crews together.
German tanks often fought as individuals. American Shermans fought as one network, a collective intelligence no rival could match.
History's lesson was unmistakable. In modern combat, survival belongs not to isolation, but to those who can communicate.